Hello friends, welcome to our channel. In this video we are going to learn the concept of strain energy. Let's see what is strain energy first. Strain energy is the internal energy which is stored in any body, which is stored in any material, which is loaded within an elastic limit. Let me explain you with a practical example. I have taken a spring. When we apply the load on the spring, it get compressed, so some internal energy is stored in the body that's allow the body to regain its original position. When you leave it, it get original position. So it works only within a elastic limit. If we apply a tensile load on to it within an elastic limit, the internal energy is stored in the body, which allow the body to regain its original position. So that's all about strain energy. Strain energy is also known as resilience. It is also called as resilience. The units of strain energy are Newton per Newton meter, Newton mm, Newton centimeter, or kilonewton meter, kilonewton mm, kilonewton centimeter. Moreover, strain energy is possible within an elastic limit. It is possible when we apply a tensile or compressive load within an elastic limit. If we cross the limit, no energy will be stored in the body to regain its original position. So it is denoted by the formula of strain energy is U is equals to sigma square by 2E into V. Units are Newton into mm. Let's see how this formula is derived. Consider a bar of length L and diameter D. When you apply a tensile load, it gets stretched to dashes bar. So let's see the graph. By using this graph, we will solve the strain energy formula. Here on x-axis deflection we have taken, on y-axis load. So this is the graph of elastic limit or proportionality limit. At this end is denotes that it is the elastic limit. If we cross this limit, it goes to elastic limit. So strain energy is stored within the elastic limit. It exists within the elastic limit. So we have considered area of this area is known as strain energy. So strain energy is equals to half, you have taken a red triangle, that is half L into B, that is half delta L and height P, and we get from Hooke's law delta L is equals to PL by AE into where P is equals to sigma into A. How? Sigma is equal to P by A. P is equals to sigma is equals to P by A. As we know, stress is equals to P by A. Here we want P, so P is equals to sigma into A. So this is how we get P value as sigma A. From Hooke's law, delta L is equals to P by A, PL by AE. Here this is how we get PL by AE. And after that, next step, we will get P by A is equals to sigma, then sigma L by into sigma into A. Finally we get strain energy is equals to sigma square into sigma square A into L, sigma square into A into L by 2E. Or we can also write strain energy is equal to sigma square area into volume, area into length, we get volume, so V by 2E. So this is how we derive the strain energy formula. If this video helped you, please like it and share to your friends who are needed, and subscribe our channel. For if you subscribe, you will be updated with upcoming videos, and press the bell icon for latest update. Thank you for watching.